Hey guys, so today we're going to be continuing on with our systems of linear equations stuff. So far we've learned how to write systems of linear equations, and we've learned one way to solve them, which is graphically. Today we're going to be looking at a second way to solve systems of equations, which is actually my favorite method of solving systems of equations, substitution. Okay, so these are the steps to substitution. First, you want to isolate one of the variables in one of the equations. Sometimes the equation will be given to you with one of the variables already isolated, but if not, that is the first step. Just so you know, it doesn't matter which variable you isolate. So you don't have to get it into like y equals mx plus b form where the y is by itself. You could get the x by itself if you wanted. So as long as one of the variables in one of the equations is by itself, that's the first step. Step two is plug that solution into the second equation. So everything on the opposite side of the equal sign from the isolated variable gets plugged into the second equation. Then you're going to solve that second equation and you'll get a number, and then you will plug that number into the first equation. Then you solve the first equation, and then of course at the end, if you have time, you always verify your solution. If you happen to have fractions in one or both of your equations and you don't like working with fractions, you can get rid of them by multiplying each term in the equation by the denominator. So we'll run through two examples, one with no fractions and one with fractions. Okay, so this first example says solve the system, and it gives us two equations, 2x plus y equals 3 and 4x plus 3y equals 5. Now, when I'm trying to decide which of these two equations I'm going to isolate a variable in, look for an equation that already has a variable with no coefficient. So x has a coefficient of 2, y doesn't have a coefficient, and then in the other equation, both the x and the y have coefficients or numbers in front of them. That means I am going to call this equation number 1 and this equation number 2. Okay, just because it's going to be easier to isolate this 3. So I'm going to start with my first equation, 2x plus y equals 3. And then I need to get the y by itself. So in this case, that just means moving the entire 2x to the other side. And so I'll do that by subtracting 2x from both sides. So that leaves me with y equals 3 minus 2x. Again, it doesn't have to be the y that you get by itself. In this case, it was just the easiest one. But we're not trying to put this into slope-intercept form. We're just trying to get a variable by itself. Our second step is to then take our second equation, 4x plus 3y equals 5. And because all of this, the 3 minus 2x, is all equal to y, I can use the 3 minus 2x to replace the y in the second equation. So that will leave me with 4x plus 3. And now instead of 3 times y, it's 3 times 3 minus 2x, since that's what I've replaced the y with, equals 5. Then, of course, I need to distribute that 3 into the brackets. So that'll leave me with 4x plus 9 minus 6x equals 5. Then I'm going to start gathering my like terms. So I'll move the 9 to the other side so it can be with the other constant. So minus 9 minus 9. That leaves me with 4x minus 6x equals 5 minus 9. And then of course I can simplify. So 4x minus 6x is negative 2x, and 5 minus 9 is negative 4. And then our last step is to isolate the x. So we divide by negative 2 to get the x by itself. And that'll leave us with x equals 2 as our solution. Our third step is to then go back to the first equation. I'm going to plug in my x value and solve for y. Now I could go back to the very original first equation, but it will actually be easier to use the rearranged version of the first equation. So I'm going to use y equals 3 minus 2x, so this whole equation right here. And then I'm going to plug in this x value of 2. So y equals 3 minus 2 times 2, which is 3 minus 4, which is negative 1. And so my solution to this system is x is equal to negative 2 and y is equal to negative 1. You may also sometimes see it asked that you write your solution as a coordinate, in which case it would just be 2, negative 1. Okay, so 2 as our x value and negative 1 as our y value. Okay, and then of course you could verify by plugging the 2 and the negative 1 into each of the original equations and doing your left side equals right side. I won't go through that because we've already shown you how to verify. Okay, so you can just check your work yourself there. That is what your verification should look like once you plug in the solutions for your x and y. Okay, in the second example that we're going to run through here, I've given you two equations. One of them contains fractions and then the other one doesn't. So our first step is just going to be to get rid of those fractions. So I'm going to, in order to get rid of this 1/4, I'm going to multiply each of these terms by 4, by the denominator. So times 4, that'll cancel out. I also have to multiply the 3/2 times 4 and the 2 times 4. Okay, that leaves me with 1x, or just x, plus, and sorry, that's just in the light there. 3/2 times 4 is 6. So 6y, and then 2 times 2 is 4. Now I can see that my x doesn't have a coefficient, or its coefficient is 1. So that means that x is going to be really easy to isolate this time. So that makes this my equation number 1. My other one will be equation number 2. So I will subtract by 6y in order to get the x by itself. So x equals 4 minus 6y. And then now that I have that variable isolated, I can move on to step 2, where I take my second equation, 3x minus 5y equals 9, and I plug in everything that x is equal to where the x is. So that'll leave me with 3 times 4 minus 6y minus 5y equals 9. Of course, then I need to multiply that 3 into the brackets. It is important that when you substitute this equation into the second equation, that you do put it in brackets so that you know the 3 has to get multiplied by both of them, since they're both equal to x. Anyway, that leaves me with 12 minus 18y minus 5y equals 9. Then I'm going to move my 12 to the other side to be with the other constant. So because it's positive 12, I will subtract 12. That leaves me with negative 18y minus 5y equals negative 3. Yes. And then negative 18 minus 5, excuse me, is negative 23y. And so, of course, I have to divide by negative 23 in order to get my y, which we could leave as, first of all, cancel out your negatives, so 3 over 23. And then that cannot be simplified any further, so we just leave it like that. Though if you did want to turn it into a decimal, you could. It's 7.6 repeating. Then we go for step 3. We're going to go back to our initial equation, but the rearranged version. So 4 minus 6y. We're going to plug in our y value. So either 3 divided by 23 or 7.6 repeating. The one thing you want to make sure of, if you're plugging it in like this, instead of like a fraction, make sure that you show that it's negative 6 times. Don't just put in 7.6 because you'll be off by a bit. Put in a bunch of 6s to show that the 7.6 is repeating. Okay, so that is then minus 46. And then 4 minus 46 is negative 42. So if you needed to write this as a coordinate, your x would be negative 42, your y would be 7.6 repeating. Okay, and then again, you could verify that with left side equals right side if you had time on a quiz. Okay, that is it for today. Let me know if you have any questions.